This is a two-step mole problem tutorial. The first thing you want to do when solving a mole problem is to read the problem, find the number that has units attached to it. That will be your starting point, and then find the unit that you are trying to go to. So in this problem, we have how many molecules are in 29.8 grams of NaCl. So 29.8 grams of NaCl, that's the number that's given and its units that are attached. So we're starting over here in the mass box. All right, I am trying to get that unit to convert over to molecules. So using this map, we have to go one way. So I'm starting here, and you move this way until you get to molecules. Well, molecules is right here in this box. So to get from mass all the way over here to molecules, well, then I'm going to have to do one step and to the mole, and then over to a second step to get to the molecule. So that's why that problem is going to be a two-step problem. At the bottom problem down here at the bottom, I have how many moles are in 29.8 grams of NaCl. So, excuse me, if I'm still starting with 29.8 grams of NaCl, if I'm going to the mole, well, then that's just a one-step problem. Any problem that has the word mole in it, that you're either given attached to a number or you're trying to find moles, then that is going to be a one-step problem. So let's set this problem up. So we're given that 29.8 grams. So I'm going to set it up like this. And here's the skeleton, how all of the problems are going to be set up. The units are going to be different on your conversion factors for each problem, depending on what your unit you're starting with and what unit you're ending with. So I know this is two steps. So that means I'm using two conversion factors. I'm going to get rid of my grams. I'm going to put grams on the bottom. And I have to go through the mole, because over here on my map that's going to the mole, and so I'm going to moles, and I want to get rid of moles. So then I write moles down here to get rid of moles so they'll cancel out. And I'm going to go from moles then to my molecule box. So I need molecules because that's what I'm trying to end with. And you can write NaCl after all of these. All right, now the numbers that go in the conversion factor, you will find those in this little green box to the left. So if you have a G, you have to calculate the molar mass of the substance. So sodium chloride's molar mass is 58.44 grams. And anytime you see the word mole in a conversion factor, you'll always put a 1 in front of that. And in front of molecules, anytime you have the word molecules, you're always going to put 6.02 times 10 to the 23rd in front of that. All right, so to do the math, now that we have the units and our numbers in place, we would take 29.8 times 1 times 6.02, hit the exponent button on your calculator, then 23, and then get a total for that. So hit equals, and then you're going to divide it by 58.44 times 1, which is just 58.44. So you're dividing it by 58.44, and you get 3.069. So we're going to make that a 7 times 10. And watch for the exponents on these. And don't forget to write it down. So 3.07 times 10 to the 23rd molecules of NaCl. The units that are on the top and appear on the bottom, the same units, they will cancel out, leaving us with just molecules for our unit. So that's how you do a one-step problem. All right, so let's do one more. Let's say that we have 14.9 liters of oxygen at STP, and I want to know how many grams that's going to be. So on my mole map, I'm starting way over here at liters. I am going to have to go to moles, and then to go from moles then to mass. So I'm going to take 14.9 liters of O2 at STP, and I'm going to get rid of liters, so I'm going to write it down there, and then since that's going to the mole, going liters to a mole, I'm going to put mole up here. I want to get rid of the mole. And the units I'm trying to go to should always end up right here in that spot. So I'm trying to get to mass. So since this was at STP, I can put 22.4 in front of liters. One goes in front of moles, one goes in front of mole, and I need to calculate the molar mass of 2 oxygen atoms, so that would be 32.00. So now the math on this is going to be 14.9 times 32, and that equals 476.8. I'm going to divide that by 22.4 times the 1, and I will get 21.29 grams of O2. So 14.9 liters of oxygen in mass would be 21.29 grams. So that's how you do another two-step problem.